Penrose is right on the implications of Gödel for consciousness, computation, cognition. Continuing on Bergson's holographic theory, that series. Penrose, in his take on the implications of Gödel's theorem for Turing computation versus consciousness, this has been quite an object of disdain by AI. Been looking at this. AI doesn't exist. People lost the plot. Interview of Penrose. It's quite interesting. By AI doesn't exist here, he means attributing our actual intelligence to AIs is just wrong. Now, I've long pointed to the significance of this particular example of non-computational thought of Penrose in Shadows of the Mind. The visual proof of a computation does not stop. A very visual proof. Let me note right off the bat, critics are constantly claiming Penrose's arguments are intrinsically tied to the microtubule notion of ORCH-OR, and the fact is there's zero tie. You can toss the poor Penrose or poor microtubule thing in the trash. Penrose's arguments remain. As with physics and AI in general, Penrose does not understand this. The computational and the non-computational rest in our metaphysic of space and time. So let's take a look at his recent explication of his interpretation. So the interviewer asks here, or describes a list of achievements of AI. And Penrose says, we have to be careful. First of all, the name is wrong. It's not artificial intelligence, it's not intelligence. Intelligence involves consciousness. And I've always been a strong promoter of the idea that these devices are not conscious, and they will not be conscious unless they bring in some other ideas. They're all computable notions. The interviewer says, but intelligence is not consciousness. Sort of echoing the determination of AI to separate consciousness from intelligence. Penrose says it depends on consciousness. That is, intelligence depends on consciousness. It depends on how you use the word. I think when people use the word intelligence, it means something that is conscious. I developed my own ideas after going to a course, you see, when I was a graduate student in Cambridge. I went to 3 courses that had nothing to do with what I was supposed to be doing. One was by Bondi on general relativity. One was by Dirac on quantum mechanics. And the third topic was on mathematical logic. And I learned about Turing machines and the notion of computability. And I learned about Gödel's theorem. And Gödel's theorem, I found it stunning because it told you that there are things that the understanding transcends the use. I think he used that word, hence in brackets. Let me put that more clearly. What Goedel does is very clever. What he does is, here's a statement. What does it mean by proving a theorem in mathematics? How do you know it's really true? Well, you prove it. What does proof mean? Well, you have these set of rules. And if you follow these rules, that makes it a proof. Now, how do you know these rules only give you truths? Well, you've looked at them carefully. The interviewer, maybe AI creates its own rules. Ah, says Penrose. No, you see, you have to be careful. This is the point. I learned from Steen, his instructor, this important thing about Gödel's theorem. He was extremely clever. He made a statement that asserts it cannot be proved by these rules. The clever thing is to make it do it. It says, you give your rules, which are usually regarded as the rules of proof, and you can put them on a computer. So that means they're computational rules. Now, I learned that there are things you cannot put on a computer. I learned this from the course, that there are non-computable things. There are things in mathematics that are not computable. What's computable mean? It means that you can make a computer. It means you have to define what a computer is. Turing had one, Church, others. They all turned out to be equivalent. So there is one universal notion of computability. Interviewer, maybe this is only a language problem. Penrose says, no, I don't agree with that. Let me describe the Gödel theorem. It says you construct a statement and you see what it means. The way you've constructed the statement, you can see what it means, and what it means is, I am not provable by those rules. And it really says that. And then you say, well, is it provable by the rules? If it says it's false, then that means it's provable by the rules. If you follow the rules, and then he starts gesturing, yes, that's okay, looking at each rule. If you follow those rules, it is true. So that means you believe the rules only give you truths. So therefore, it's true that it's not provable by the rules. If it's false, therefore it's provable by the rules. So therefore it's true. So it has to be true and not provable by the rules. And I found that amazing. Interviewer: here I do not understand why an AI cannot create its own rules. Penrose, a bit frustrated: it doesn't know that they're true. That's the whole point about the Gödel theorem. The whole point, as far as I'm concerned, about the Gödel theorem is how do you transcend the rules? And that's what you do by understanding them. You understand why they're true. It's not that you use the rules. You understand why you use the rules only gives you truths. You understand why the use of the rules only gives you truths. And that's how you can prove things that go beyond the rules, by knowing why they're true. So here's a rule. For any polygon, the sum of the exterior angles is given as, just go to the turquoise equation there, n times 2r plus 4r, where r is a right angle and n the number of sides. You can apply that turquoise equation mindlessly using that rule and always get the sum of the angles. But why is it correct? Wertheimer gave an example, thinking about the problem. He was wondering, why do the angles of a polygon always sum to 360 degrees? He started initially with that intuition of a closed space. Then, a little while later, he had this intuition of, well, you could take a line and you could break the line and you'd create an angle, a delta there. And then later on, he started to realize, well, if you break a line all the way around the polygon, rotating, breaking the line, creating delta after delta after delta, you end up with a series of deltas, and then you collapse them all into that space there, which is obviously 360 degrees. So that is the 4r, 4 times 90, 360. Now we ask, well, how about that other term? Where does that come from? Well, from this. Always on each side, there's going to be the two 90-degree angles. So you have the two 90-degree angles times the number of sides, or n times 2r. Now you've got an understanding of the rule as visual transformations. Transformations. This is the key. Transformations are over time. Take another case from Wertheimer. He's observing a classroom, and the children are learning the standard rule for computing the area of a parallelogram, where you drop the verticals from the corners there and you make a rectangle, and then compute the area. So he gets up on the board and draws a rotated parallelogram. And the students exclaim they don't know what to do anymore. What should we do? So, in other words, their algorithmic rule-based understanding instantly failed. They didn't really understand the rule. Yet Wertheimer observed a 5-year-old girl, given the same problem, had a cardboard parallelogram. She simply folded it into a cylinder and asked for scissors to cut the cylinder to make it a rectangle so she could compute the area. So, a dynamic transformation. This is understanding the rule. So Penrose goes on, and knowing why they're true. Well, what does it mean? Well, it means you understand them. What does understand mean? You've got to be conscious of it. The wording is clear. It means you have to know what you're doing. You have to know why it's true. Not that they're true, or you have to be told that they're true. That's not the point. You have to know why they're true. And why they're true means understanding them, and understanding them requires being conscious of them. So understanding. This, in my opinion, is the definition. The perception of invariance over time-extended, that is continuous, time-extended transformations. Why a function of consciousness? Why non-computable? Well, this brings us to time. Penrose, physics, AI are all stuck in the classic metaphysic of space and time. They're hopelessly behind. Why? Because Bergson explained this and exposed the metaphysic in 1896. We start with the concrete extensity of the material world. Our lake there, the shore, the lake transforming indivisibly over time, duration. But what we do cognitively is place a mental mesh over concrete extensity. It's, as it were, a principle of infinite divisibility, as Bergson said. It's the abstract three-dimensional continuum of points, positions. And time is simply the fourth dimension, the dimension of instants in this space. Motion is a series of positions, instants. If I move the cylinder across or through the continuum, it's seen as a series of positions. That's instants. Also each position corresponds to an instant. But this is an infinite regress. Between each pair of points, to account for the motion, we have to introduce a new line of points. And then between each pair of those points, yet another line, an infinite regress. It's also an absurdity, because it's saying motion is a set of immobilities, a complete absurdity. So this is the classic metaphysic. It's an abstract space, which includes an abstract time, the fourth dimension of the abstract space. This is an ideal limit of the physical world. It's never reached in the concrete physical world. It has no positive reality, no ontological status. But it is the framework of mathematics, physics, computation. In this metaphysic, there's ever only one discrete state or instant. This one, then this one. Each state is gone as the next arrives. There can be no experience of continuity. This relates to the fundamental implication. Each instant of the motion of that cylinder through the continuum, each point corresponds to an instant of the all of space. My cube's there. But each cube has the time extent of a mathematical point because of the infinite division at the hypothetical end of the infinite division is a mathematical point. That is a point with no beginning or end. Therefore, each cube has no time. Therefore, each cube cannot be the cause of the next cube. Space 1 cannot cause space 2, cannot cause space 3. Each cube is frozen, static, immovable. No further progression is possible. This is why, as Bergson noted, Descartes said, well, now we have to have a God that creates cube after cube after cube. In other words, physics fools itself. There has to be continuous creation. The classic metaphysic is simply hiding this fact. So for Bergson, motion is indivisible, not a series of points or positions / instants. View it as a melody, he thought. Each note, or say instant, is interpenetrating, permeating the next, forming an organic continuity, each note reflection of the entire preceding series. The transformation of the universal field is indivisible. It has this indivisibility. The brain is embedded in this field. It's integrally part of the indivisible transformation. This is why the processes of the brain are non-computational. If we take Bergson's theory a little bit further beyond the exposition of the classic metaphysic, we see that he thought the field is holographic, a holographic field indivisibly transforming. And the brain, in effect, formed a modulated reconstructive wave passing through this hologram, the holographic field, specific to an image of a portion of the field. So it's a reconstructive wave specifying continuous external events, coffee stirring, the spoon moving, the hand moving, the cylinder opening, closing, specifying continuous events. As a holographic field, It's a panpsychic field. It has holographic means it also has an elementary awareness defined throughout. Indivisibly transforming implies it has a primary memory. So the classic metaphysic is a derivative of the brain's cognitive development. It has, again, no positive ontological reality. It and its, quote, computations, all taking place in the classic metaphysic, mean nothing to the functioning of the brain, to its perception, to its cognition. Penrose, I would say, is assuming a physics based on something other than the classic metaphysic. He's just not sure what. But the classic metaphysic is the foundational framework of AI. He also assumes something else that AI rejects. Namely, he assumes conscious cognition uses imagery. At the foundation of AI, the theorists threw away the mental image. This is xenon Pylytian. I noted it a few times now. In other words, the image has lost all its picture-like qualities and become a data structure, meeting all the requirements of the form of representation set forth in earlier sections. In other words, the image is redundant to the data structure. Seeing the image has been replaced by a set of common, elementary, completely mechanical operations such as testing the identity of two symbols. AI does not need imagery. Yet, in this particular proof that Penrose gave, the example of a computation that does not stop, a visual proof, adding successive hexagonal numbers invariantly makes a cubical number, folding the hexagonal number, stacking it over the previous, always making a cube. To understand it as a proof, this is again the perception of invariance over a global transformation. One has to see the globality of the transformation to perceive the invariance defined over it. This requires consciousness, that is, a consciousness that is integrally part of the indivisible flow of time. It is the transformation of the universal field is itself a primary consciousness. But imagery requires, firstly, a model of the origin of the image of the external world, that is, also known as the hard problem. AI has none. So, back to microtubules. And the interviewer says of the computer, of the current AIs, but it's only a black box. A statistic machine? Response to Penrose. Penrose says, but it's a machine. It's not conscious. Yeah, I think people have lost the plot. He says, with respect to The Emperor's New Mind, his book, he said, the whole point in my train of thought was, we've got to find something in physics. I'm a physicalist. I believe that whatever is going on in our heads, whatever creates consciousness, is part of the physical world. Interviewer. Black box is also part of the physical world. But what do you mean by a black box? Interviewer says, well, it's an input-output thing. Yes, says Penrose, but that doesn't help because you don't know what's inside. What kind of physics is inside the black box? Interviewer says, maybe a new physics? Yes, but physics of a particular kind. What I'm claiming is that the physics that's in that box has to be non-computable physics. Hence, his speculation on the microtubules in the brain, forming the basis of a non-computable physics. But the other route, as just noted, the brain is embedded in the indivisible, thus non-computational, not the classic metaphysic transformation of the universal field. So now we have, shall we say, a redefinition of physics. The use of the classic metaphysic is, again, an ideal limit. It's only an approximation to the real, indivisible, transforming field in the physics actually implied. Postscript. An interesting reaction by the AI enthusiast, the AI Doom people, for example. This one, where Liron reacts to Sir Roger Penrose, same discussion we just looked at, Liron being the channel guy. There's a few amazing misconceptions to note first. For example, he notes that Penrose's arguments are intrinsically tied to his concept of microtubules, an ORCH-OR. And since they consider the microtubules very suspicious and implausible, Penrose's arguments collapse. Well, we've seen why his arguments aren't tied to that in truth at all. Another one, meaning lies in the vector spaces of large language models. And we've, that is AI, solved the symbol grounding problem. Neither of these are true. I discussed this, for example, the symbol grounding problem in this one on neural scaling laws, also implied in RKJI. But Liron sees the relation to the Chinese room because we're talking understanding. And the question is, does Searle understand the Chinese that he's translating via his translation rulebook into English? And Liron says, well, the book of rules there would actually be a large language model like ChatGPT, blazing at light speed in a high-dimensional vector space, and it would understand. Well, I've discussed this whole problem in this one, the Chinese room. The simple answer is nothing of this computational approach is going to explain or escape the classic metaphysic. But on the other hand, AI folks will often say no one, including Searle and Penrose, knows what understanding is. Well, we've just seen a definition. That is perception of invariance over global transformations over time. And that applies equally well to the Chinese room problem. When we say she turned the parallelogram into a cylinder, or the man stirred the coffee with a spoon, we are invoking the perception of dynamic events with invariance laws over time. That is, language is a mediating device to create perception of a transformation, an event, with its invariance laws. There's nothing Searle is doing or large language models are doing to affect this. They cannot create the perception of an event with its invariance laws over time. And in this, we're right back to where we started with Penrose and what understanding actually is. In any case, always the sad, rank ignorance of Bergson. So next, we'll see, again, this book holds a whole lot of additional arguments that I haven't gone into on this whole conception.